This final video is going to leave you with a very interesting idea. The example that we're going to work through says, so set up an iterated integral, which gives you the area of the region D below, and you're like, okay, well, area, that's a Calc 1 concept, right? We learned how to find the area, but area of a region like this way back in Calc 1, so why do we need to do this in Calc 2? Because it's fun. Okay. The idea that we're going to do is try and connect kind of 2D and 3D here. So you can actually view an area as a double integral. And here's how. Okay, so if we were to imagine first a volume, okay, so imagine volume. Okay, so we're working kind of over in the 3D world. Okay, so volume more generally, if we think of this as a box, right, we know volume is area of the base times the height, right? And so, well, area of the base, well, we're just going to call that area times height. Okay. Well, so then how can I link these things to get area, or how can I set this idea up? Well, it is exactly saying that we can get the volume and the area will be exactly equivalent when the height is 1, right? So that is to say, we could create a iterated integral to find this volume, okay, but the height has to be 1. Okay, so we can say to find this area, we can say this is the double integral over our region D is what we called it, okay, region D of the function 1 dA. Okay, and that's going to give us our area. Okay, and then now we know how to do all this. We can say, okay, well, this is an elementary region, and particularly it is, let's see, I think if we set this up as a type 2 region, it might be easiest. Yeah, let's set it up as type 2. We could set it up as type 1. I'm going to do type 2. Okay, and if I do that, so I'm thinking, okay, type 2 region, we have to restrict y. Okay, so y is between 0 and 1, and then x has to be bounded between two functions, and it's precisely those two functions. So on the lower end, we're going to have the square root of y, and on the upper end, we're going to have y plus 1. Okay, so then integrating this, we get 0 and 1, and then root y to y plus 1 of 1 dA. And I could go ahead and calculate, or sorry, not dA, this would be dx dy. Okay, so we can go ahead and compute this, but I'm going to leave that for you to do, and we would just get the area of this enclosed curve. The big idea was we can connect volume and area as long as we allow the height of our figure to be 1, and we can go forward with that. Alright, so that's going to wrap up videos this week, and we'll see you later in class.